Welcome to the session on gamma function and beta function. The gamma function denoted as gamma of n, it is defined as the definite integral from 0 to infinity x raised to n minus 1 into e raised to minus x dx, where n is greater than 0. For n is equal to 1, it is gamma 1, which is equal to integral from 0 to infinity x raised to 0 into e raised to minus x dx, that is x raised to 0 is 1. This is equal to integral from 0 to infinity e raised to minus x dx, that is on integration e raised to minus x divided by minus 1 between the limits 0 and infinity, which is equal to, here if we put x equal to infinity, the upper limit, that is e raised to minus infinity, which is tends to 0 minus the lower limit is 0, that is e raised to 0 is 1 divided by minus 1, which is equal to 1. That is gamma of 1 is equal to 1. The beta function is defined as, the notation is beta of mn, which is defined as integral from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx, where m and n are greater than 0. This is the definition of beta function. For m equal to 1 and n equal to 1, beta 1 1 is equal to integral from 0 to 1 x raised to 0 into 1 minus x raised to here also 0 dx, that is integral from 0 to 1 dx. That is x between the limits 0 and 1, that is equal to 1 minus 0 equal to 1. That means beta 1 1 is equal to 1. These are two standard values. These two integrals can be used to evaluate the definite integrals of these two forms. Now, we have to derive the recurrence formula connecting the gamma functions. That is, the formula is recurrence formula for gamma function. The formula is gamma n is equal to n minus 1 into gamma n minus 1. We can derive this formula by the definition of gamma function. Gamma of n is equal to the definite integral from 0 to infinity x raised to n minus 1 into e raised to minus x dx. Using integration by parts, we can write this integral as we take the first function as x raised to n minus 1 second function is e raised to minus x. Therefore, the first function x raised to n minus 1 into integral of the second is e raised to minus x divided by minus 1 between the limits 0 and 1. Sorry, the limits are 0 and infinity, minus integral of derivative of the first function, that is the n minus 1 into x raised to n minus 2 into integral of the first, that is integral of the second, that is e raised to minus x divided by minus 1 dx. Limits are 0 and infinity. This is equal to value of this term is 0, because if we put the lower limit here, 0 into e raised to minus 0 divided by minus 1 means it will become 0. Now, note that limit x tends to infinity. Here x raised to n minus 1 into e raised to minus x means x raised to n minus 1 divided by e raised to x. If we apply the limit as x tends to infinity, we will get this as infinity by infinity form, which is indeterminate. Now, by using the L'Hospital rule, we can evaluate this as limit x tends to infinity. Here we differentiate both numerator and denominator. We get n minus 1 into x raised to n minus 2 divided by e raised to x. Again, if we use this limit as x tends to infinity, this will become infinity by infinity form. But if we use the L'Hospital rule once again, we will get limit x tends to infinity. Here the derivative is n minus 1, n minus 2, x raised to n minus 3 divided by e raised to x. Obviously, this numerator will tends to 0. Therefore, limit of this is 0. Therefore, gamma of n is equal to 0 minus, here minus of minus is plus n minus 1 into integral from 0 to infinity x raised to n minus 2. N minus 2 can be written as n minus 1 minus 1 into e raised to minus x dx, which is equal to n minus 1 into, comparing with the definition of gamma n, we get here this is the definition of gamma. Here instead of n minus 1, here n minus 1 minus 1, that is just replaced n by n minus 1. Therefore, this is gamma n minus 1. That is gamma of n is equal to n minus 1 into gamma n minus 1, which is the recurrence relation. Now, we can express this gamma function as n factorial, that is gamma n is equal to n factorial. Sorry, gamma n is equal to n minus 1 factorial. Gamma n can be expressed as a factorial form. Gamma n is equal to n minus 1 factorial, not n factorial, n minus 1 factorial. For n is an integer, we can, from this recurrence relation, we can write this is equal to n minus 1 into gamma n minus 1 can be written as n minus 2 into gamma n minus 2. This is equal to n minus 1 into n minus 2 into, again we use the same recurrence relation here instead of n minus 2. Therefore, this gamma n minus 2 can be written as n minus 3 into gamma n minus 3. Proceeding like this, we get gamma n as n minus 1 into n minus 2 into etc. The last is 1 into gamma 1, here 2, 3, etc. But gamma 1 is 1, therefore, this is equal to 1 into 2 into 3 into 4 into etc. up to n minus 1, that is n minus 1 factorial. Gamma n is equal to n minus 1 factorial. Note that from this recurrence relation, gamma n is equal to n minus 1 into gamma n minus 1. We can write gamma n plus 1 is equal to, here we just replace n by n plus 1. Therefore, this term is n plus 1 minus 1. That is gamma n into n into gamma n. We just replaced n by n plus 1. We can write the same recurrence relation as gamma n plus 1 is equal to n into gamma n, or gamma n is equal to gamma n plus 1 or 1 by n into gamma n plus 1. Note that by the definition of gamma function, if n is 0 or a negative integer, the gamma function does not exist. But if n is a negative fraction, we can find the value of gamma using this relation. For example, for n less than 0 and n is not an integer, we can evaluate the gamma by using this relation. For example, take n is equal to minus 3.5. Then gamma of minus 3.5 is equal to, using this relation, we get 1 by minus 3.5 into gamma minus 3.5 plus 1. That is equal to 1 by minus 3.5 into, here minus 3.5 plus 1 is minus 2.5. That is gamma of minus 2.5, which is equal to 1 by minus 3.5 into, once again we use this relation, we get 1 by minus 2.5 into gamma of minus 2.5 plus 1. That is equal to 1 by minus 3.5 into 1 by minus 2.5 into gamma of this is 1 minus 2.5, that is gamma of minus 1.5, which is equal to 1 by minus 3.5 into 1 by minus 2.5 into, once again we use the same relation, we get 1 by minus 1.5 into gamma minus 1.5 plus 1. This is equal to 1 by minus 3.5 into 1 by minus 2.5 into 1 by minus 1.5 into, here this is gamma 1 minus 1.5 means gamma of minus 0.5, that is equal to 1 by minus 3.5 into 1 by minus 2.5 into 1 by minus 1.5 into, we use once again this relation, we get 1 by minus 0.5 into gamma minus 0.5 plus 1, that is 1 by minus 3.5 into 1 by minus 2.5 into 1 by minus 1.5 into 1 by minus 0.5 into, this is gamma 0.5. Gamma 0.5 means gamma 1 by 2, which is root pi. Therefore, this is equal to minus 3.5 into minus 2.5 into 1 by minus 1.5 into 1 by minus 0.5 into root pi. That is here minus 3.5 is a negative fraction which can be evaluated. Gamma of minus 3.5 can be evaluated using this relation. That means in general, if n is a negative fraction, we can use this relation to evaluate the corresponding gamma. Now we have to derive the value of gamma 1 by 2 is equal to root pi. By the definition of gamma function, gamma n is equal to integral 0 to infinity x raised to n minus 1 into e raised to minus x dx, where n is greater than 0. Also note that gamma 1 is equal to 1. By definition, we can write gamma 1 by 2 as gamma 1 by 2 is equal to integral 0 to infinity x raised to 1 by 2 minus 1 into e raised to minus x dx. That is integral 0 to infinity e raised to minus x into, here x raised to 1 by 2 minus 1 is x raised to minus half dx. Now we use the substitution t square equal to x, so that 2t dt is equal to dx. When x is equal to 0, t also equal to 0. For x equal to infinity, t tends to infinity. Therefore, limits are the same. This is equal to integral from 0 to infinity e raised to minus t square into x raised to minus 1 by 2 means t square raised to minus half dx is 2t dt. That is equal to integral from 0 to infinity e raised to minus t square. Here t square raised to minus half means t raised to minus 1 into t raised to 1. That is t raised to 0. T raised to 0 is 1. Therefore, this 2 can be taken outside. Therefore, this is equal to 2 into integral from 0 to infinity e raised to minus t square dt. That is gamma 1 by 2 is equal to 2 times integral from 0 to infinity e raised to minus t square dt. Also, we can write gamma 1 by 2 as 2 times integral from 0 to infinity e raised to minus s square ds. We just changed the variable in this integral. It will not affect the value of the integral by the property of definite integral. Integral a to b f of x dx is same as integral a to b f of y dy. Therefore, we write two expressions for gamma 1 by 2. Now, we multiply these two. In the left hand side, we will get gamma 1 by 2 into gamma 1 by 2. That means gamma 1 by 2 the whole square is equal to, in the right hand side 2 into 2 is 4, integral from 0 to infinity e raised to minus t square dt into integral from 0 to infinity e raised to minus s square ds. Which is equal to 4 times. We can express this product of these two definite integrals as a double integral, because the both the limits are same for both for the two integrals. We get this is equal to 4 into double integral from 0 to infinity e raised to minus of t square plus s square dt ds. Now, let us change into polar coordinates using the substitutions t equal to r cos theta and s equal to r sin theta. Use these substitutions t equal to r cos theta and s equal to r sin theta. Here variation of t is from 0 to infinity. That means 0 to infinity means the positive side. For this also 0 to infinity. Therefore, this double integral is on the positive portion of this two TS plane. Therefore, we can take the limits of theta as from 0 to infinity, 0 to pi by 2. By this substitution, we get t square plus s square is equal to r square into cos square theta plus sin square theta. That is t square plus s square is equal to r square into cos square theta plus sin square theta, which is equal to r square. T square plus s square is equal to r square, which is a this represents a circle in the TS plane whose radius is r. Therefore, if we change to polar coordinates, we can take the limits of theta as 0 and pi by 2. Now dt ds, which is equal to modulus of, the Jacobian j into dr d theta, where j is equal to determinant of dot t by dot r, that is cos theta, into dot s by dot r, determinant of cos theta here, dot s by dot t by dot theta, that means derivative of cos theta is minus sin theta, therefore this is minus r sin theta. Here derivative of s with respect to r, that is sin theta, and derivative of s with respect to theta, that is r cos theta. Which is equal to r cos square theta minus of r is plus sin square theta, that is r into cos square theta plus sin square theta, which is equal to r into 1, that is r. Therefore this dt ds will become r into dr d theta. dt ds is equal to r dr d theta. So this gamma 1 by 2 the whole square is equal to 4 into double integral e raised to minus this is r square dt ds is r dr d theta. The limits are theta varies from 0 to pi by 2 and r varies from 0 to infinity. Therefore here 0 to pi by 2, this integral for with respect to theta, and this is from 0 to infinity. This is equal to 4 into integral from 0 to pi by 2. Here the first integration is with respect to r. Therefore we can take this d theta here, integral 0 to infinity r into e raised to minus r square dr. That is we can consider this double integral as a product of two integrals. For the evaluation of this integral, we use the substitution as r square equal to some u. We use the substitution r square is equal to u, so that 2r dr is equal to du, then r dr equal to du by 2. When r equal to 0, u also equal to 0. When r equal to infinity, u also equal to infinity. Therefore, the limits of integration remains the same. Therefore, this is equal to 4 into integral from 0 to pi by 2 d theta into integral from 0 to infinity. Here r dr is du by 2. E raised to minus r square means e raised to minus u du by 2. That is equal to 4 into integral from 0 to pi by 2 d theta into 1 by 2 into, on integration this is e raised to minus u divided by minus 1 between the limits 0 and infinity. Therefore, this is equal to 4 into integral from 0 to pi by 2 d theta into 1 by 2 means 4 by 2. This is e raised to minus infinity tends to 0 minus e raised to 0 is 1 divided by minus 1, which is equal to, this is 1 into 4 by 2 is 4 by 2 means 2 into integral 0 to pi by 2 d theta, which is equal to 2 into theta between the limits 0 and pi by 2, that is equal to 2 into pi by 2 minus 0, that is pi. That means gamma 1 by 2 the whole square is equal to pi. Taking the square roots on both sides, we get gamma 1 by 2 as root of pi. That is the gamma value of gamma 1 by 2 is root pi, which is a standard value. Gamma 1 by 2 is equal to root pi.